Good day, Ma'am Presi. I'm Mitchie Gaspar from Team B, and I'm about to discuss a little bit of information about CPU scheduling and a specific type called round-robin algorithm. Every device is an operating system that controls and manages all its operations for it to function according to the user instructions. Operating system is the reason why we can get a quick response from our devices every time we give instructions to it. But it's not just the operating system. There is a scheduler that helps the operating system to organize and execute a set of processes efficiently. A process scheduler schedules different processes to be assigned to the CPU based on particular scheduling algorithms. There are many algorithms that are used to schedule processes actually. And round robin scheduling is one of these algorithms. This algorithm is effective in time sharing, real time operating systems. It gives reasonable response time, but it suffers from several disadvantages such as high turnaround time and waiting time. Also, it suffers from many context switches. Round robin is a preemptive algorithm that switches between processes to make sure that each process get a small unit amount of time. Sorry, small unit of CPU time. So, in this project, we want to showcase how round robin is scheduling works by making a program that schedules each process in a round robin manner. This project will benefit both students and teachers. It can help students to learn what is round robin algorithm and be able to know how it works. Also, teachers can use this as their learning material to teach students about round robin algorithm. So that's it for the introduction. Now, the objectives and scope and delimitations will be discussed by my fellow group mates, Louie Joy Tablan and Gabriel Manganti.
For the objectives, this project aims to develop a program that implements a round-robin scheduling to schedule a set of processes. Specifically, it ought to achieve the following. First one, use Python as the programming language in developing the program. For the second one, be able to develop a program that can validate all its input. And the third one, generate a table containing all the information of the processes, such as its arrival time, completion time, burst time, turnaround time, and as well as its waiting time. Also, develop a program that can compute the average turnaround time and as well as the average waiting time. And lastly, generate an error-free Gantt chart for all the processes.
For the scope and limitation, first the scope. The program can accept more than 8 processes. The minimum value is 3 and the maximum value is 10. This means that the program can accept less than 3 processes and more than 10. Next is the burst time within the minimum value of 1 and the maximum value of 8. The arrival time is 1 in the minimum and 15 ms is the maximum. Next is the delimitation. The quantum time is constant. This means that we already declared the quantum time in our code, which in our case, we set is as 3. Next is the Excel file are temporary and being replaced or renewed after every program runs. Lastly, the Excel file cannot accept new data while it is open.
So now for the demo, uh, what we have here is a set of data that has four process IDs as well as different arrival time and different burst time. So I have already prepared the solution for it as well. We have the Gantt chart here, and we have the completion time, turnaround time, and waiting time for each processes. And I have already computed the averages for both turnaround time and waiting time. So now what we are going to do is that we will run this process in our program. So let's begin. So the number of processes here, as we can see, is 4. So we'll put 4. So the process ID P1. For P1, it has 2 as arrival time and 3 for the burst time. So now P2, 1, P3, 4, 15, and 5. So after we input all the data from the first set, we have here is a message that says your table and Gantt chart has been printed into this directory. So now we will check it if it's here. So there, as we can see, the Excel file was generated by the program itself. So now let's try to open it. So here's the Excel file, the computer generated solution. Let's check if it's the same as our solution. So here, as we can see, P2 has an arrival time of 1 and 5. So it is the same as this one. Completion time, turnaround time, waiting time is the same. So P1 has an arrival time of 2 and 3. Yeah. It is also the same, as well as all the processes that has been printed by the computer. Completion time, turnaround time, and waiting time. So now let's check the average. So the average turnaround time here is 6.25 as well, and the waiting time is 2. So as we can see, it is the same. So now for the sequence, let's check. Hold on, sorry. Uh, there. So as we can see in the sequence, P2 has been executed first, then P1, then P2, then P3 two times, and then the CPU has an idle time of 2 seconds because P4 arrived at 15 seconds. Then the final process that has been executed was P4. So as we can see, all the solution that was generated by the program was the same as the solution that we made for the first set of data.